Okay, let's continue our explanation now in section 2.2. This section talk about two things, something called distance and something called displacement. Let's, for example, just again, distance is a scalar quantity and displacement is a vector quantity. Scalar just means a magnitude. Vector represent, and displacement, our vector, represent magnitude plus direction. Okay, let's go over here down and see what's gonna happen. I'm gonna say an example and the one similar to the book. Let's say, for example, I have a rectangular park. Its edge is called A, B, C, D. And let's say, for example, there's a human over here standing. Okay, this guy has to go from A to B, then to C. Let's put some value in general. Let's say the distance from A to B is 30 meters. Distance from B to C is what? 40 meters. Okay, so over here, let's say what is the difference between both of them, between distance and displacement? Distance, it means I care about total journey I traveled. Let's say, for example, so this guy moved from A to B. A to B is 30 meters. Then he moved, then again what, to C. He stopped at C. From B to C is also 40 meters. So distance from A to C gonna equal to 30 plus 40 equal to 70 meters. That's what I mean by distance. Now let's go to something called displacement over here. What do I mean by displacement? Okay, and displacement, I care about two things. Put this in your mind from now till next year, the one after. Displacement, I take care about where I started and where I finished. Okay, let's say same example. This guy, let me just redraw the triangle over here. It's gonna be more clear. A, B, C, D. Okay, let's see, this is the number. Here gonna be 30, here gonna be 40. Same question. The guy told you over here he moved from point A, then he moved to B, then he moved to C. So he stopped what? At C. Since he stopped at C, I'm gonna create what we call it vector, something called vector. Okay, just a little reminder, what I mean by vector in general. Don't think too much of it. We don't need that much of math. Vector is just a value plus direction. Direction يعني arrow. Okay, I started from A and moved to C, so I'm going to draw, for example, like a small segment connecting A and C. And of course, since I moved from A to C, I'm gonna put an arrow over here. This arrow represents direction. I moved from A to C. Okay, how to get the displacement value over here? As you can see, over here I have a rectangle, so it should be 90. This represents hypotenuse. Okay, so hypotenuse is gonna be, so AC equal to radical 40 squared plus 30 squared. Let me just calculate it. 40 squared. So represent 50 meters. So displacement AC is just only 50 meters. This is the first idea. Put something in your mind. Just